All right, welcome to day 8, notes, 7.6, factoring higher degree polynomials using the factor theorem. So we're just going to continue on what we did the other day, and we're going to factor these higher degree polynomials completely, okay? So just like we did the other day, let's go ahead and get right to it. I want you to plug this equation into your calculator. If we try to group that by factoring, we cannot do so. So throw it into your calculator and find a 0. Okay, so pause the video, give yourself a second to do that, and come back. What you should notice is that there are no zeros in the table, right? So what did we talk about if we can't find a 0 in our table of values? We then actually have to go and calculate the 0, all right? So I'm going to tell you what I got when I calculated the 0. If I looked at the graph, I could see that it crossed the graph, or the x-axis, 3 times. So I'm going to calculate the 0 of the far left 0. And when I do that, I get x is equal to -3/2. Okay, if you have any questions with the calculator aspect, let me know and we will certainly go through that. So now I'm going to verify that this is one of the zeros using synthetic division. So -3/2 goes in the corner, goes in that box. And looking through our polynomial, I don't need any placeholders. So we've got 12, -20, -37, and 30. All right, so go ahead, carry out the operation. When we bring the 12 on down, we've got 12 times -3/2, we're at -18. Adding to -20, we're at -38. Multiplying by -3/2, we're now at +57. Adding, we get 20. Multiplying, we get -30. And we do get a 0 for the remainder. So therefore, we know that -3/2 is a 0. But remember, because we have this fraction, this rational number here, we have to then divide all of these coefficients by that denominator. Okay, so the real coefficients that we're dealing with are going to be 6, -19, and 10. Okay, so now we are at a polynomial that is 6x squared minus 19x plus 10. Okay, so we can factor this. I'm going to jump straight to what those factors are, all right, and then we'll talk about all of the factors of this polynomial. So this factors as 3x minus 2 and 2x minus 5. Okay, so we have that from this polynomial, okay, from the 6x squared minus 9x plus 10. But let's go back and kind of think about this 0. Okay, so if that's the 0, what is the factor that we get from there? Okay, so I'm going to kind of scooch down here. If that's our 0, our factor, we kind of work backwards, remember? We multiply both sides by the denominator. So we're at 2x equals -3, and I need to get that -3 over to the other side and get this equal to 0. So I have 2x plus 3 equals 0. So this guy here is our factor from the 0, x equals -3/2. So now what we need to do, though, is we need to write p of x in terms of all of its factors, so we can do so. P of x is equal to the factor of 2x plus 3. We got that from our calculator. And we use synthetic division to get 3x minus 2 and 2x minus 5 as the remaining factors. So this is our completed polynomial in factored form. And all of these factors have integer coefficients. All right? So there we have it. Let's move on to the next example. Moving on to example 2 here, having our polynomial p of x equals x to the 4th plus 2x cubed minus 13x squared minus 14x plus 24. And we are trying to factor this, right? So since there's 5 terms, I can't really factor that by hand. So we're going to jump to our calculator, throw it into your y equals, and find 1 0 on your calculator. You should be able to find 1 using your table of values this time. Okay, so go ahead and do that and verify. I'm going to jump right into the one I found from the calculator and our table. I found that one of the zeros is x equals 3. Okay, so just a reminder, if x equals 3 is the 0, then the factor is going to be x minus 3. So just kind of keeping that in mind. Okay. All right, so 3 is going to go into the corner. I take a look at the polynomial that we have, just double checking we don't need any placeholders. So we can go ahead and carry out the synthetic division. Let's whittle this polynomial on down, right? So our coefficients 1, 2, negative 13, negative 14, and 24. So let's carry this out. Bring the 1 on down, multiply, we get 3, add to 5, multiply to 15, add the 2, multiply to 6, add to negative 8, and we get negative 24 when we multiply, which is good because then our remainder is 0. So we did find a 0, right? So we verified that 3 is the 0, so x minus 3 is our factor. So where does this put us, right? This now puts us at a polynomial that's x cubed plus 5x squared plus 2x minus 8. Now, if we tried to factor the rest by hand, grouping 2 and 2 would be really our only option, and we should see that it won't work. So what we need to do is we need to go back to our calculator and find another 0. Okay, so go back to your table of values and see if you can find another 0. When I go back, I can see, I can see that x equals 1 is another 0. Okay, so now what we're going to do is we're going to put that 1 in the corner, and we're going to use this polynomial, and we're going to whittle that down further. So that's what we're going to use synthetic division with. So now we have a 1, the 5, the 2, and the negative 8. And now we can carry out the synthetic division. Drop the 1, multiply to 1, add to 6, multiply to 6, add to 8, multiply to positive 8, and now we're down to 0, and there's our remainder. So this is good, okay? So let's just talk about the zeros so far, or the factors that we've gotten from our calculator, right? We got x equals 3 is a 0, so x minus 3 was our factor. We have x equals 1 is a 0, and now we just showed that that is in fact a 0, so another factor we have is x minus 1, okay? But now we have this remaining polynomial, okay? So now we have to factor, x squared plus 6x plus 8, okay? So this is easy for us. Hopefully we can factor this pretty quickly, and we get x plus 4 and x plus 2, okay? So now, just stating what the polynomial is in completely factored form, all right, we have p of x is equal to x minus 3, x minus 1, x plus 4, and x plus 2. So there may be times where you have to use your calculator twice or maybe more, all right, to get to a quadratic. So the goal with synthetic division is once we get to a quadratic, like we did here, we are done, okay? We are done using our calculator, and we factor this by hand from here, all right? So we've got one more example of factoring a higher degree polynomial before we look at one other topic. So let's move on to the next page. Okay, so let's factor this big polynomial completely, all right? So the first thing we do, well, I noticed that there's an awful lot of terms there, so we are going to just throw it right onto our calculator, okay? And you should be able to find a 0 on your calculator using your table of values, all right? So from the calculator, verify that you get x equals negative 1. So I'm going to just start making my list of my factors, okay, and rewriting p of x in terms of that. So if negative 1 is a 0, we know we have one factor of x plus 1. Let's just verify that. We better verify that with our synthetic division. All right, so negative 1 goes in the corner. I take a look at our polynomial. Do we need any placeholders? Our answer is no, so we can go ahead and write our coefficients. 1, 5, 10, 10, 5, and 1. Carrying this out, bring the 1 down, multiply to get -1, add to 4, multiply to -4, add to 6, multiply to -6, add to 4, multiply to -4, add to 1, and multiply to -1, and we get 0. So, okay, we verified -1 is in fact a 0, so therefore we can go ahead and say, all right, x minus 1 is our factor. Okay, so now if we take a look, where does that put us, right? That puts us at x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. We can't factor this by hand, all right? So we need to go to our calculator and see if we can find another 0. But if you go to your calculator, you're not going to see another distinct 0, okay? So what we can do from here is now let's go ahead and plug this into our calculator, okay? So erase what you have in y1, plug this into calculator, okay? And we're going to pull a 0 from this new polynomial. And what you should get from your calculator is that when you plug that polynomial, x to the 4th, 4x cubed, etc., you're going to get a 0 to be -1 again. So it's just a repeated 0, okay? So is -1 a 0 of this polynomial that we just whittled down to? We can verify that. So -1 is going to go in the corner, and now we're going to use synthetic division with this polynomial right here. So 1, 4, 6, 4, and 1. And we carry it down, 1, multiply to -1, add to 3, multiply to -3, add to 3 again, multiply to -3, add to 1, multiply to -1, and we get 0. Okay, so -1 is a 0, which means x plus 1, another factor of x plus 1 for p of x. Okay? All right, so now where does that lead us? Now we have the polynomial from here, from those coefficients. So now we are at, x cubed plus 3x squared plus 3x plus 1, okay? Now, if you look back on your calculator, don't change anything. If we tried to factor this, we probably could, right? We can factor this by grouping. Actually, no, we cannot. We can't factor that by grouping. So if we can't factor this by grouping, we then need another 0 from our calculator. But you should notice that if you go back and you look at any zeros from this polynomial that you should have in your calculator still, you won't see any other zeros besides -1. So let's go ahead and plug this guy into your calculator. Okay, so plug that guy into calculator and see if we can get another 0. Okay, and what you should find is on your calculator, you should find, hey, guess what? X equals -1 is a 0 to this polynomial here. So now we're going to use synthetic division another time with those green coefficients. So 1, 3, 3, 1. And we whittle it down. Bring the 1 down, multiply to -1, add to 2, multiply to -2, add to 1, multiply to -1, and we get 0. That's good. So that tells us that that 0 is truly a 0 to the polynomial, which means we can go ahead and add another factor of x plus 1 to p of x. Okay? So now where does that lead us? Well, now we have x squared plus 2x plus 1, and we have whittled it down to a quadratic, so we no longer need our calculator. We can go ahead and factor this by hand, and guess what? We get another x plus 1 times x plus 1. So we're going to go ahead, add those to our polynomial, x plus 1 times x plus 1. So what's another way we could talk about p of x? I'm going to kind of shoot down here. We could say p of x is really equal to the quantity x plus 1 raised to the 5th power. Okay, so that's just a case of where we have repeated zeros. So what happens is if you look back to find another 0 on your calculator, you're not going to see any other distinct zeros. So you could plug in the new polynomial that you kind of whittled it down to, and you can then see anything there that's a 0, that's considered a new 0, and we can use that for synthetic division. All right, now we're going to look at sum or difference of like odd powers, okay, and see how we can factor these next two examples. Okay, these next two examples are finding the sum or difference of like odd powers, and we're factoring them. Okay, so we did this with sum and difference of cubes, but now we're going to look at a pattern so that we can do this with any like odd power. So 5th, 7th, 9th, etc. Okay, so if we're going to look at this first example here of factoring p of x is equal to x to the 5th plus 32. I really want to kind of think about this as x to the 5th plus 2 to the 5th, okay? We always want to write it as a sum of two like odd powers, okay? So I'll kind of go through it. So our players in the game, okay, are going to be these two. So I'm going to kind of put those off to the side. We're going to be dealing with x, and we're going to be dealing with 2, okay? Now, our first factor is pretty straightforward, okay? Our first factor is simply the 5th root of x, and we always are going to use plus here, okay? Plus the 5th root of 32, okay? Now, I'll tell you why we're always going to use plus, all right? Now, our next factor, what's going to happen is the degrees of x, our first term, go down. And the degrees of 2 go up. So what do I mean by this? Okay? All right. So because we have a factor, our first factor is this x to the first power. That means we essentially took one x out, and that means we have x to the 4th that remains, okay? So we're going to have an x to the 4th, and our 2 is going to start at 0, okay? So 2 to the 0, all right? And then we are alternating signs every single time. So we always start with a plus, and then we switch signs from here on out, okay? Now, the degree of x goes down, so now it's x to the 3rd, and the degree of our 2 goes up, times 2 to the 1st power, okay? We switch signs, so now it's a plus. Our degree of x goes down, x squared. The degree of 2 goes up, 2 squared. Switch signs, now it's minus. The degree of x goes down, x to the 1st. The degree of 2 goes up, 2 cubed. Switching signs, the next is a plus. Our next term, the degree of x goes down, x to the 0. The degree of 2 goes up, 2 to the 4th. And now we're done, because once we get x to the 0, we know we are done, okay? And now we just clean this up. So when we clean this up, I'm going to erase this part here, okay, so I have some room. All right, so now where are we? Well, our first factor is x plus 2. And now this term here, x to the 4th times 2 to the 0, well, 2 to the 0 is just 1. So this factor, or this term, is x to the 4th. All right? When we clean up this here, x cubed, 2 to the 1st is 2. So we have a minus 2x cubed. Okay? Cleaning this term, 2 squared is 4. All right? And it's a plus 4x squared. Cleaning this term up, we've got a minus, okay? 2 cubed is 8, x to the 1st is x, so minus 8x. And then finally this last one, x to the 0, that's just 1, and 2 to the 4th, so we get plus 16. So here's our fully factored version of those like odd powers, x to the 5th plus 32, okay? Let's try this next one to see if we really got it down. And then we have to talk about the players, okay? So if we look at this next guy, x to the 7th minus 128. Now remember, I said we always want to think about it as plus, okay? Because if we think about it as plus, then our signs will always start the same way. So again, this is like saying the quantity x to the 7th plus, and now we want to rewrite 128 or negative 128 as a perfect power of 7. So that's just going to be negative 2 to the 7th. So the players in the game are x and negative 2, okay? So the x powers go up, the negative 2 powers, oh, I'm sorry, I reversed that. Reverse that. X powers go down, and the negative 2 powers go up, okay? So our first factor, as we're going through this, leave room, okay? Our first factor is always going to be an x. We always start with a plus, okay? And our next is negative 2. So this is really x minus 2, right? But if we always think about it as starting with a plus, then we can't go wrong, okay? So now our next factors, since I pulled an x out of x to the 7th, we now start with x to the 6th. And then our other player is negative 2 to the 0, changing signs. So since we started with a plus, it's now a minus. X's are going down, x to the 5th, and then negative 2 to the 1st power. All right, changing our signs, it's now a plus, x to the 4th, negative 2 to the 2nd. All right, changing the signs, it's now a minus. X goes down, so x cubed, negative 2 cubed. Changing our signs, plus, x goes down, so x squared, negative 2 to the 4th. Changing signs, I'm going to go below, minus, x goes down, x to the 1st, negative 2 to the 5th. Last one, changing our signs, x goes down, so to 0, and negative 2 goes up to the 6th. And now we go through and we clean up every term, okay? So our first factor, x plus a negative 2, just becomes x minus 2, okay? X to the 6th times negative 2 to the 0. Well, negative 2 to the 0 is 1 times x to the 6th. So we're just left with x to the 6th. This next one, negative 2 to the 1st power is negative 2. Negative 2 times this negative goes to plus. So we end up with plus 2x to the 5th. Okay? All right, this next one is going to be negative 2 squared. So that goes to positive 4. We have a positive in front, so it's going to stay positive, 4x to the 4th. All right, this next one is a minus, but let's see what happens. Negative 2 cubed is negative 8 times this negative. That's going to go to plus 8x cubed. All right, this next term is a plus, but let's see if it stays that way. Negative 2 to the 4th power is positive 16 times this positive here. We're going to get plus 16x squared. This next term here is a minus, but it's negative 2 to the 5th power. That's negative 32 times this negative. That's going to go to plus 32x. And then finally, this x to the 0, that just is 1. Negative 2 to the 6th power, that's going to be positive 64 times 1 just stays plus 64. And now we are done. Okay, so the key with these is 1, identify the players in the game. Okay, rewrite your sum and difference of like odd powers as a sum of like odd powers. Okay, identify the players, identify which one's going down, which one's going up. This guy goes down, this guy goes up. All right, we'll get more practice. If you have questions, let me know.